Hello everyone. As you know, we have already started the series of lectures on the physics. So, in the interference pattern, already we have discussed the two important topic, Fresnel biprism and also the basic concept of physics. So today we will take another topic, and the topic is known as Newton's ring. Who is Newton and what are Newton rings? That we learn through this video. Actually, Isaac Newton is very brilliant mind, and he discovered the Newton ring. In interference pattern, the special case of the light, that is known as Newton's ring. How the rings are formed when there is plano-convex lens and glass plate put together, and there is air gap from both sides and rings are formed. So Newton rings is a special case of interference pattern. So we understand the experimental part, also learn the some basic concept, diameters of the dark and bright ring. If we consider that in the previous case, in the Fresnel biprism, we get straight fringes. In this we get the circular fringes, and Newton rings are more accurate for the calculating the wavelength of light than Fresnel biprism, because somehow the least count part is the more than the Fresnel biprism. So let us understand the first diagram and then Newton ring. So Newton ring may understand that suppose this side there is a lens, there is a source, a single source. From this source, rays may not parallel. So we put the focus, suppose this is L1 lens, we put the source on the focus of this lens. So rays become parallel after this. And these parallel beams, rays incident falls on the glass plate, which is inclined at 45 degree to the incident light. So this is simply glass plate, and if you see that when the light incident at 45 degree, it falls normally to the angle is 90 degree. This is property of that is 90 degree. So when these rays falls on the special arrangement is there is glass plate. After that we have the lens that is called plano-convex lens. So this is air gap on both sides, air gap here and here. So rays are incident here and they reflected from this side, and they reach, because this is transparent film, transparent plate, glass plate, and after that we will see here there is a microscope M. So we can observe the rings, they are formed at this point and they are circular like this, they are increasing circular. So this is glass plate, simple glass plate, and this is my lens, you can say L2 lens. This lens is different from this lens. This is called plano-convex lens. So here is gap from both sides. So one can understand the basic concept of this. S is any source, monochromatic light, maybe sodium light. Ray may not parallel, so we make parallel ray by this lens. After that ray become parallel. These parallel rays incident on the glass plate, which is 45 degree toward the incident light. So beam falls normally on the arrangement, that is glass plano-convex lens and glass plate. So rings are formed, and these rings somehow known as this form. This is rings. These are rings. These are called Newton rings. Sometimes there is spot is these are called Newton rings. Now, how these forms? Because there is single source. How that single source act as coherent source. So basic concept we have to understand that how that single source become the coherent source. So we have to understand the basic concept of the rings form. How the So see the other part of the diagram. Suppose this is my glass plate. This is my glass plate, and on this glass plate there is a plano-convex lens on that glass plate. Now suppose this is air gap on both sides, this is gap on both sides, air gap. Suppose a ray incident from some angle, suppose incident from this angle, so ray may reflect from this side, it may go like this. This is single ray, and it bend because somehow it is denser to rare, so it is maybe this side, and again it reflect from this side. So this is 2, this is 3. So corresponding one ray, that is incident ray, we got 2 rays, and they is known as reflected rays. Now this is air gap. Now, so this is let us point P, where one reflection from this point, other reflection from this point. So what is the path difference? This is my lens, this is my glass plate, simply glass plate. So the single source, after that single source, how the 2 rays are emitted. The concept is again arises ki how that single source can produce a coherent light, because these are 2 dependent on this source. Okay, so they are derived from the single source, derived from ray 1. So 2 and 3 ray, they may interfere and they can produce interference pattern at the suitable conditions. Now let's understand the effective path difference. So the path difference, that is path difference play important role between these two. Path difference, that is delta equal to 2 mu t cos r plus theta. This is my path difference. Okay, now where is theta, what is role of r? Let us see here. So t is thickness, air film that has thickness small t, angle is the refraction angle is r, theta is base angle. So in this case, because rays are incident normally, so there is no r. If r is 0 and theta is very small, then you can say this is your cos r plus theta, you can write equal to 1. So my path difference will be 2 mu t minus lambda by 2. This is my path difference. Now this path difference may be equal to somehow for bright, for dark. So for bright, you know the path difference is lambda by 2 and lambda. So for bright ring, condition for the bright, that is constructive interference. So this path difference, that is equal to delta, that is equal to n lambda. So this may be equal, so you can put 2 mu t minus lambda by 2 equal to n lambda, or you can say 2 mu t equal to n lambda plus lambda by 2. Okay, so one can write in this form like 2n plus 1 lambda by 2. Okay, where n is your start with 0, 1, 2, 3, like so on. So it can also written as 2n minus 1 lambda by 2, because n start, or we can write it is 2n minus 1 lambda by 2. Okay, where n is equal to start here that 1, 2 and 3. Here n start with 0, 1, 2, 3, because if n is 0, lambda by 2, if n is 1, it is lambda by 2. So conditions are same. So when this condition satisfy, the film will appear bright. Okay, now second condition for dark ring के लिए, for dark ring we write that 2n minus lambda by 2, delta is equal to 2n minus 1 into lambda by 2. So in that case, your this path difference will satisfy 2 mu t minus lambda by 2 equal to 2n minus 1 into lambda by 2. So if we simplify this, then your 2 mu t become this simply your n lambda. So these two conditions are understand when these two conditions satisfy, your film will appear dark and bright. So now we are in position to calculate the diameters of the various films. So films are formed. So now understand the diagram part and see the how the diameters can be calculated. Okay, so suppose karo this is my diagram, and diagram again same diagram. This is my your glass plate. On that glass plate there is a plano convex lens is placed. Okay, now this is my, I can extend this, we can extend the whole part, whole circle, or in this understand the main part that this is somehow is center of curvature. Okay, and you know this is your small t, it is the thickness of air film. Now in this case this R, this is capital R. Okay, and now this is small r, this is small r. So small r and capital R, this center part is there, this is central part, this is one corner, that is air film. Now you can put the name, that is A and B and let us say P. So small r is the radius of ring there which are formed. Capital R is the radius of curvature of lens. So totally they are different because small r is the radius of that lens, that rings they are formed, and capital R is the. So there is a property of circle that is known as, suppose this is my any point, let us say Q point. Okay, so this is your R, and what is this? This is your capital T, this is small t. So property circle is that we can write here R into R, I mean AQ or AQ property of circle. So AQ into QB equal to that AO, OQ and Q, that P. So simply substituting values, this R into R equal to this OQ is that your small t thickness, and this is your 2R minus T. So this way R square will be 2RT minus T square. Okay, so now understand that T is the small portion, T is very small and R is capital R. You know T is very small and capital R is large. So in that case we can neglect T square neglect, and what is the remaining part? R square become 2RT. Now this T can be calculated as T equal to R square by 2R. This is formula for thickness of air film. How to find thickness of air film? That is the from this formula. One can write also then this, suppose your R equal to 2R equal to D diameter. Okay, so here one can write here ki D square upon 8R. This is also thickness of the air film. So one can calculate the thickness if you know that capital D or small r, that is diameter or radius of that rings. Also the length that is used to form the Newton rings. Then you can calculate thickness of air film. Okay, now what is basic concept here to understand diameters? Because rings are formed and number of rings in this form, they are alternately dark and bright. So how to find diameter? So rings are in this form, like rings are formed. These are known as Newton rings. Okay, so how to find the diameter of that each dark and bright? So let us take one by one. The first case, let us take diameters of bright ring. I mean there are so many bright ring, there are so many dark ring. So how to find diameter of bright ring? See, in that case, already we know the condition. What is condition for bright ring? 2 mu t equal to 2n minus 1 into lambda by 2. This is the condition where n is already we have defined n equal to 1, 2, 3 and 4, where n equal to 1, 2, 3 and so on. Now here you know that what is t? Now already we have calculated t thickness of the film, that is r square upon